So, hi guys, welcome once more to this YouTube channel, Best Science Brain YouTube. Today we are presenting solution to NECO GCE November 2023 Physics examination. If you are not subscribed to the channel, go to the channel's name, Best Science Brain. Under the channel's name, you see the subscription button that looks like a tiny bell. Tap on the button only once and get subscribed to the channel for more videos. If you're writing WAEC, JAMB, NAPTEB, NECO, or whatever examination you are writing, subscribe to the channel and remain focused as we go to the solution for NECO GCE Physics solution. The first question, we're going to part 2, where you have the major marks of the theory. Part 2, the first, number 12 says, the instruction there says answer 4 questions from this part. So we're going to look at only 4 questions. 12AI says give 2 applications of centrifugal force. Solution, the first, washing machines use centrifugal force during the spinning in order to extract excess water from clothes. Number 2, applied in centrifuges to separate substances of different densities. Examples, cells, proteins, and DNA. So there are 2 major applications of centrifugal force, one in washing machine, another in centrifuge. 12AII says, why are curved rows banked? Why are curved rows banked? Number 1, to reduce the reliance on friction. To keep vehicles on the road. That's number 1. To reduce the reliance on friction to keep, or you say in order to keep vehicles on the road. Number 2, to increase stability and prevent skidding. Number 3, to allow vehicles to maintain higher speeds while navigating turns. So that is 12A III. 12BI says state Archimedes principle. State Archimedes principle. Solution, when a body is totally or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. When a body is totally or partially immersed in a fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. That's Archimedes' principle. 12BII says, how can the relative density of sand be determined in the laboratory? How can the relative density of sand be determined in the laboratory? Solution, the relative density bottle is first cleaned and dried and weighed empty, full stop. It is then reweighed when about 1/3, that 1/3, full of sand, full stop. The relative density bottle containing the sand is now filled up full with water and reweighed, full stop. Finally, the bottle is emptied, cleaned of any sand particle and filled with water alone, full stop. The weight of the bottle and water is obtained. Then the calculation that follows it. Mass of empty bottle equal to M1. Mass of bottle plus sand equal to M2. Mass of bottle plus sand plus water equal to M3. Mass of bottle plus water equal to M4. Mass of water filling the bottle equal to, bracket opens, M4 minus M1, bracket closes. Mass of water having the same volume as the sand, bracket opens, M4 minus M1, bracket closes, minus M3 minus M2, bracket closes. Hence, relative density of sand equal to mass of sand as the numerator all over mass of equal volume of water equal to, bracket opens, M2 minus M1, bracket closes, all over, bracket opens, M4 minus M1 bracket closes minus bracket opens M3 minus M2 bracket closes. So this is how to find the latent density of sand in physics. 12C says a shot is fired from the nozzle of a cannon with a velocity of 180 meters per second, full stop. If the angle of inclination of the nozzle is 30 degrees to horizontal, comma, calculate the horizontal distance the shot covered. Take G as 10 meters per second square. Solution, taking U, that U is initial velocity as 180 meters per second. Our angle to inclination is 30 degrees, that theta. We're looking for range. So formula for range equal to U squared sine 2 theta over G. Substituting, U is 180 squared, then sine 2 times 30, the angle is 30 all over G. Will come down there, equal to 180 squared, then sine 2 times 30 is 60, sine 60, then G is 10, that's acceleration due to gravity. Then if 180 squared gives us 32,400, then sine 60 is 0.8660 over 10. When we evaluate that, our range becomes 2,805.84 meters as the answer to the question. We go over to number 15. 15A says, enumerate 2 industrial applications of electrolysis. Solution is applied in the electroplating of metals, e.g. silver plating of steel. 2 is applied in the extraction of highly electropositive metals such as sodium, calcium, aluminium from their ores. Is applied in the production of gases and certain compounds such as, example, chlorine and sodium hydroxide. Going to 15B says, give one advantage of iron over steel as magnetic material. Solution, iron can be easily magnetized than steel, or you can say iron produces a stronger magnet than steel. 15C says, define resonance in an AC circuit. Define resonance in an AC circuit. Solution, this is condition in an AC circuit when the inductive reactance, bracket opens, SL, bracket closes, and the capacitive reactance, bracket opens, SC, bracket closes, are equal in magnitude but opposite in phase, comma. Hence, the impedance is minimum and the current is maximum. 15D says 2 cells, each of the EMF 3 volts, and internal resistance is 0.6 ohm and 0.4 ohm, comma, connected in parallel, are connected to a 3 ohm resistor. I draw a circuit diagram of the arrangement. So let's go to the solution for 15D I first. Let's look at the circuit diagram for arrangement. You can see the diagram. The 2 cells are in parallel, 3 volts each. The first one has a resistance of 0.6 ohm under it. The second one has 0.4 ohm under it. They look at the notation for the cell, the parallel lines. The positive end should be longer than the negative end. So look at it very well. So look at the direction of the current flow current coming down and then going up again. Then underneath, you have the 3 ohm resistor. So this is the diagram for the arrangement. Let's go back to II. It says calculate the total resistance in the circuit. Total resistance in the circuit. So total resistance in the circuit, first of all, we have to combine the internal resistances. There are 2 internal resistance, 0.6 and 0.4, and they are in parallel. We use a shortcut method using R equal to product R1 times R2 all over their sum, R1 plus R2. So we have 0.6 times 0.4 all over 0.6 plus 0.4. That gives us 0.24 over 1. Gives us 0.24 at the total internal resistance. Then the total resistance in the circuit we can represent using RT. Now becomes R. R is the external resistance, which is 3 ohm, plus small r, which is the internal, which is 3 plus 0.2 for giving us 3.24 ohms. So we'll now go over to question triple I. Says calculate current passing through the 3 ohm resistor. So you see that the 3 ohm resistor is down there. The current passing through this 3 ohm must be the current flowing out for the battery. So we have to look at the solution. So we'll now look at the net EMF is 3 volts. When two batteries are connected in parallel, the net EMF is nothing but the EMF of one of the batteries. You don't have to say 3 plus 3, or you don't have to say 1 over 3 plus 1 over 3. So when batteries are in, or cells are in parallel, the net EMF is the EMF of one of the cells, is the equivalent to each other. But if they are different from each other, I take the highest value at the net EMF. So since the EMF are the same, take 1 as the net EMF, 3 volts. Total internal resistance is 3.2. Total resistance, is 3.24 ohms. Using the formula I, current equal to E all over R plus big R plus small r. And big R plus small r represent using RT with the total resistance. So substituting the value, have 3 all over 3.24. Solving, our current becomes 0.926 amperes to 3 significant figures. We move to number 16AI. Says itemize two effects of surface tension. Itemize two effects of surface tension. Solution. The first one, insects and small objects float on water due to surface tension. Number 2, it leads to formation of spherical droplets of raindrops or tap water. 16AII says enumerate two ways of reducing surface tension of water. Enumerates 2 ways of reducing surface tension of water. Solution. Additional surfactants such as soap and detergent. Then 2, increasing the temperature of water. The first one is additional surfactants such as soap and detergents, and then 2, increasing the temperature of water. Going to 16B says differentiate face-centered cubic from body-centered cubic unit cells. I have a table there, and there are many differences. The first one under face center says atoms are located at each corner of the cube, and additionally at the center at each face. This gives a total of 4 atoms per unit cell. Then for body center, number 1, atoms are packed at each corner of the cube. There is 1 at the center of the cube. This gives a total of 2 atoms per unit cell. Number 2, under face-centered. Face-centered could be that FCC means face-centered cubic crystal. Has a coordination number of 12 because each atom in the interior is in contact with 12 neighboring atoms. Then number 2, under body-centered could be BCC, that's what it means, has a coordination number of 8. Number 3, face-centered crystal, that's FCC, has a higher packing efficiency, 74%, compared to body-centered crystal, 68%. Number 3, under body-centered crystal has a lower packing efficiency of 68%. Number 4, face-centered crystals, cubic crystals, generally have a higher density. Number 4, under body-centered cubic crystal has a lower efficiency. So number 16C says explain diffusion in water using copper sulfate crystals. Solution: copper sulfate crystal dissolves in water, leading to random motion of its ions, IONS, and collision with nearby water molecules, full stop. The diffusion of copper sulfate in water involves the spontaneous spread of the particles from an area of high concentration, bracket opens, near a crystal, bracket closes, to an area of lower or low concentration through random motion of particles driven by thermal energy, full stop. Over time, this leads to a more uniform distribution of copper sulfate through the water until dynamic equilibrium is achieved or established. (16D) says a relative sample has a decay constant of 0.8 per second and a count rate of 300 at the beginning of an experiment. Calculate is I half-life. So let's go to half-life first. Solution 16DI. T half represents half-life equal to 0.693 over K. That's the connection between the two of them. Then substituting, since they gave us the decay constant, K is the decay constant at 0.8. Then we replace K with 0.8. So we divide 0.69 by 0.8, get 0.8663 seconds as our half-life. Number 2 say we should find the count rate after 2.599 seconds. We go to the solution, 16DII. So use the equation log A0. That A0 represents initial count rate, original count rate, all over AT. That is count rate after a time of 2.599 seconds. That's 80 equal to KT all over 2.303. That is an equation required here. So log our A, or the original count rate, which is given to us in the equation as, why is it? Given to us as 300 initial count rate at the beginning of the experiment. So we'll come back, log A 300 all over 80, which is the count rate at a time t, and that time we're looking for is the time of 2.599 seconds, equal to our k decay our k is the decay constant, which is given to us as 0.8. Then the time the count rate we're looking at a time of 2.599 seconds. So replace t with 2.599 all over 300. So you can see that the substitution done accurately. Then solving out. If you solve at the right hand side of the equation, 0.88 times 2.599 all over 300, we're going to get down 0.00693. Then we now, to find 300 over 80, we'll find log inverse of 0.00693, and that will give us approximately 1.0161. Then we'll make 80 the subject. 80 now becomes 300 all over 1.0161. That'll give us 295.2 as our final answer. 295.2 as our final answer. Move to number 14A that says draw a wave diagram of two wavelengths to illustrate destructive interference. So look at the solution. The vertical axis plus y meter up there. Then down we have minus y meter. We have this origin as 0. That axis we have t seconds. So we have how many loops here? We have 4 loops. 4 loops giving us 2 wavelengths, because from here to there is half wavelength. That node to node half wavelength. To another node 1 full wavelength. And that node again half wavelength, and that node again 1 full wavelength there. So we have 4 waves. So this will represent our wave 1, while this one, the dotted one, represent our wave 2. So these are 2 waves moving together to create consorting interference and giving us a total of 2 wavelengths. So be careful with the diagram, don't make mistake. So having done that, we go to 14B. These 2 instruments that use reflection of light in their operation. Solution, you have the periscope, you have the kaleidoscope, periscope and kaleidoscope. You can see add other ones like binoculars and microscope, just any 2, which is okay. 14C says this is between sound waves and infrared waves. Sound waves and infrared waves. Solution. Sound waves, number 1, they are mechanical waves and require material medium for their propagation. The under infrared, the electromagnetic waves and do not require material medium. The number 2, sound waves are longitudinal waves. The mechanical waves, number 2, they are transverse waves. So number 3, sound waves travel the speed of the medium. The number 3, under infrared, travel the speed of light, which is 3 times 10 to the power 8 meter per second. So difference between sound wave and mechanical waves have been itemized for you. So 14D says name 2 applications of echo. Solution 1, using sonar system to determine the depth of sea. 2, ultrasound devices use echoes to create images of internal body structures. Number 3 is used for determination of speed of sound in air. So any 2 can go. There are many uses this anyway. When I go to 14E, says a wave of frequency 20 Hz has a speed of 0.8 meter per second in the shallow region of a ripple tank. Calculate is 1 wavelength in the shallow region. Let's go to this one first. For this 14EI, wavelength is unknown, frequency is 20, velocity is 0.8, or in standard unit. Wave velocity equal to wavelength times frequency. Making wavelength the subject, wavelength becomes velocity over frequency, which is going to be 0.8 over 20. So you divide to get your final answer, and that will likely give you 0.04. So wavelength here should be 0.04 meters. Okay. Number 2 question says, find the speed in the deep region with a wavelength of 0.03 meter. Find the speed in the deep region with wavelength of 0.03 meter. Go to the solution. We're now looking for velocity or speed. Wavelength is 0.0 meter. Frequency remains the same 20 because in wave, frequency is constant. Frequency does not change. So if the frequency still remains the same 20. So velocity becomes lambda times frequency. So 0.03 times 20, that gives us 0.60 meter. That becomes our velocity of the water wave in the deep region. So we have solved 4 complete questions on this NECO GCE examination, Physics 2023 November GCE Physics Theory. Remain connected to the channel. If you are not subscribed to the channel, move up to the channel right now. Best Science Brain, you see a bell under the channel's name, Best Science Brain, say subscription bell or subscription. Tap on it only once and get subscribed so that videos will be coming your way on tutorials in science, chemistry, physics, and mathematics, and also solutions to examination questions will be displayed on the channel from time to time. So get connected. If you are writing any of the examination WAEC, NECO, GCE, NABTEB, JAMB, even if you are in your first CS year in the high institution, in tertiary institutions, we are going to bring topics that are of interest to you. Stay connected always. Thank you.